In this video, I'm going to remind you how to transform linear equations. Now, what we mean by transform is with respect to an equation. It means to morph that equation or turn it into another format by rearranging the variables and symbols, but still have it represent the same thing. What I mean by that is we would take an equation, for example, like a equals b times h, and just rearrange those three variables mathematically and have it come out looking different. So we have morphed the original equation, a equals b times h, into these other two versions using the same variables. Let me show you what I mean by that and why we would do something like that. If you look at the area formula for a rectangle, a equals b times h, the a represents the inside of the rectangle, the b represents the length of the side, and the h represents the height of the triangle. And typically you'll know two of those three variables in order to find the missing part. Well, the way you're probably most used to seeing it is to be given a side length and a height and use those two measures to find the area of the whole rectangle. What I'm talking about here, though, is maybe you're given two parts, you're given the area and you're given the base and you're asked to find the missing piece, in this case the height. So if you're asked to find a piece other than the area, other than what the equation is solved for, then you might want to rearrange your equation and have it look ready to go. So what I mean by that is taking this equation a equals b times h, dividing both sides by b in order to eliminate the b from the right hand side. And if you eliminate the b from the right hand side, all you have left is the h on the right hand side. H would be equal to a over b, or a divided by b. If I use the values from my problem, I would just insert those values in for a and for b and find out that that missing piece, the height, is 5 inches. Now, you're not going to be solving formulas. You're really just going to be rearranging formulas or rearranging random equations using the rules for solving equations. So that's what I want you to focus on now. When you transform an equation, you just follow the steps for solving equations, where we undo operations in order to isolate a particular variable. For example, in the equation y equals mx plus b, you're familiar with that equation as being the slope-intercept form of a linear equation. But what if I wanted to rearrange it? What if I wanted it to be solved for x? If I want to solve it for x, then I have to move everything away from the x. And I move the parts of the equation by undoing them one at a time. So in this case, I would undo or move things away from the x as follows. I'm going to start by subtracting b on both sides. And when I subtract the b on both sides, I'm left with y minus b is equal to m times x. But I haven't solved for x yet, so then I have to get x by itself by dividing both sides by m. And when I divide both sides by m, and this is the weird part, you really can't divide by m. You don't know what m is. So this is what I mean by just rearranging the equation, putting the parts of the equation in a different place based on the solving equation steps. So as I finish this problem, in example 2, we've changed y equals mx plus b to the format x equals y minus b over m. We have just solved it for x. I'm going to go through a couple other examples for you, and then I'm going to have you do one, or two, or three. So here's my next example. I've given you the formula for the perimeter of a rectangle, 2 lengths plus 2 widths, and I'm asking you to solve it for L. Before we get started, I want you to think to yourself, if you're asked to solve for L, that means you're focusing on the L. That means the L is the equation that I want isolated. So here we go. We're going to isolate the L by subtracting 2w on both sides, and then after subtracting 2w, then you're going to divide by the 2 in front of the L. I'm talking faster than I'm working. Just like this. So in the end, you end up with L is equal to P minus 2W divided by 2. Now, I'm writing or here because I want you to think about this. When I divided both sides by 2, I divided the whole side on the right side by 2. I divided the whole side on the left side by 2. But once again, I can't actually divide by 2 because this numerator is like a chunk of information. However, sometimes you can split the numerator, but you have to be very careful because you have to split each part. So I'm going to split the numerator and say p could get divided by 2 and 2w could get divided by 2 separately. If I do it that way, then the 2's cancel on the right-hand term. 2w divided by 2. The 2's cancel right here, and you end up with just 1w. So p over 2 minus 1w is equal to L. What I've done is I've morphed this equation in 2 different ways, but the ending equation or the ending result is the same as the original, just in a different order. So with this, in this case, we have L equals p over 2 minus w, or I can say L is equal to p minus 2w, all divided by 2. That one may have been a little tricky because you're just not used to seeing them that way. Let's look at another one you might come across, transforming from standard form to slope-intercept form. As you remember, standard form is the orange one here, ax plus by equals c, and I want to transform it to slope-intercept form. But I'm going to put some numbers in there for you just so you have something to look at. 3x minus 2y equals 8. That equation is what we say in standard form. I want you to transform it so it's in slope-intercept form, meaning right now my x and my y are on the left-hand side of my equation. I don't want both of them on the left-hand side. I want only the y on the left-hand side. So it should look something like this, or play out something like this. I want to move everything away from the y. I'll start with my 3x, get it away from the y by subtracting 3x on both sides. I'm subtracting because the 3 was positive. When you subtract 3x on both sides, it goes away on the left, and on the right-hand side we get 8 minus 3x, or negative 3x plus 8. Then I need to get rid of the negative 2 in front of the y. So since negative 2 is being multiplied by y, I'm going to divide by negative 2. Now notice on this problem, I didn't divide the whole side by negative 2. I'm dividing each part by negative 2 so that I can keep track of my work, or so that in the end I can see the parts of the equation in slope-intercept form better. So I'm going to continue. I'm going to reduce the left-hand side. I get y equals, on the right-hand side, negative 3 divided by negative 2 just reduces to 3 halves. So 3 halves x minus 4, because 8 divided by 2, or let me do it this way, negative 2 divided by negative 2 is a 1, and 8 divided by negative 2 is a negative 4. That's why I wrote minus 4 down here. Now I want you to try. Here's the equation I'm going to give you to work with. 5x plus 3y is equal to 6. I want you to convert that equation or transform that equation to slope-intercept form. That means solve for y. So pause the video, go write it down, solve for y. Isolate the y. Get y by itself. And when you're done, press play and see if this is what you did. You need to isolate the y. That means get everything away from it. We do it in a certain order. We always save the coefficient of y for last. So the first thing you're going to do is subtract 5x on both sides. After you subtract 5x, then you can divide by the 3. So when I divide both sides by 3y, and I'm dividing each part by 3y, I get y equals negative 5/3 x plus 2. That's what you should have gotten also. Here's another one for you to try. I want you to solve the equation AB minus D equals C. There's no numbers in this problem. Don't worry about it. AB minus D equals C, and I want you to solve it for B. That means get the B by itself. Get everything away from the B. Hopefully you paused. I went too fast. Hopefully you paused, worked it out. This is what it should have come out to. When you add D on both sides and then divide by A, you end up with B equals C over A plus D over A. Or you could have divided the whole right-hand side by A and gotten C plus D divided by A. All right, let's try one more. This time, I'm going to ask you to take the equation a equals 1/2 bh and transform it so that b is isolated. In other words, I don't want it to say a equals, I want it to say b equals. So on your paper, work this one out, isolate the b, and then you will have transformed that equation. It should work something like this. Now, seeing that fraction in my equation, I've been trained to always get rid of my fractions first. So I'm going to multiply both sides of my equation by 2. If I multiply by 2, the right-hand side 1/2 reduces to 1, so there's no fraction over there anymore. Left-hand side is 2a. Then I only have one thing to do to get the b by itself, and that's divide by h. So in the end, I get b is equal to 2a divided by h. Now, that's the way I did it. I'm assuming, because a lot of students will do this, I'm assuming that probably you approached the problem and you said to yourself, 1/2 times b times h means that to get the b by itself, I'm going to have to divide by the 1/2 and divide by the h. There's nothing wrong with that plan, except that after you reduce on the right-hand side the 1/2 and the h and you just get the b, even though you think you might be done, you're really not. That 1/2 in the denominator is a no-no. You're not supposed to leave fractions in the denominator of any mathematical expression. It's considered a complex fraction. We don't want to leave it that way. You don't want to have a fraction within a fraction. So I'm going to clean it up by getting rid of that fraction on the bottom by multiplying both the numerator and the denominator by the denominator, the common denominator. Let's say that. So I'm going to multiply the top by 2 and the bottom by 2. 2 over 2 is 1, so I'm not really changing my equation at all. And my result is 2a over h is equal to b, which is exactly what I got the first time around. All right, so in conclusion, I want you to remember 3 things. 1, transforming just means morphing or rearranging the equation. No big deal. To do that, to transform, we always just solve by undoing each part of the equation to get whatever variable you've been asked to isolate on one side by itself. And then lastly, if your equation has any fractions in it, you want to clear those fractions first by multiplying both sides by the denominator, or if there's more than one fraction, multiplying by the common denominator. So at this point, I'm pretty sure that you now know how to transform linear equations. Good luck!